Good day, everyone. The topic we shall be treating today is mensuration. Mensuration as it has to do with solid shapes. Mensuration is an aspect of mathematics that involves measurements of lengths, volumes, and then areas. Actually, there are a whole slew of formulas or formulae that are relevant to mensuration. Here you have surface area of cubes, cuboids, prism, cylinder, cone, sphere, and so on. And then of course there are volumes as well. So it will do a whole lot of good if you go through these notes and learn or memorize some of these formulae or formulas. First of all, we will be dealing, or in this video, we'll be treating volumes of common solids. And then here we have, as we have here, we have cuboid. The volume of a cuboid is L raised to power 3. You can see a cuboid here. A cuboid, volume of a cube is L raised to power 3. L is the length of one of its sides. Remember, a cube has all its sides equal. So the length of one of its sides raised to power 3, that is the volume of a cube. And then of a cuboid, the volume of a cuboid is length times breadth times height. And then the volume of a cylinder is pi r square h. Pi multiplied by the square of the radius, then multiplied by the height of the cylinder. So we'll take one example first, and the example we have here is a car petrol tank is 0.8 meters long, 25 centimeter wide, and 20 centimeter deep. How many liters of petrol can it hold? We are given the length, the width, and then of course the depth. This shows that the tank is about the shape of a cuboid, but there's a small trap here. The length is given in meters, while the other values are given in centimeter. So it will do us a whole lot of good, or the right thing to do here is to convert all the units to centimeter. So 0.8 converted to centimeter will give us 0.8 centimeter, 0.8 times 100, which will give us 80 centimeter, which is what we have here. So then we can now calculate for the volume of the petrol tank. But when we calculate this time around, we are going to have in centimeter cube. Then we are going to convert that centimeter cube to liters. So the volume of the tank is length times width or breadth and times the height or depth as it is here. So the length is 80 centimeter, the width which is 25 centimeter, and then the depth which is 20 centimeter. Everything here gives us 40,000 centimeter cube. 40,000 centimeter cube. But the question says that we should get the volume in liters. Now 1 liter is 1,000 centimeter cube. So how many liters will give us 40,000 centimeter cube? When you cross multiply 40,000 times 1 will give you x times 1,000. So to get the capacity of the tank to be 40,000 divided by 1,000, and then it will give us 40 liters. So the tank can hold 40 liters of petrol. Now we have another second question here, which is below is a prism. Below is a prism whose cross section is a trapezium. The trapezium parallel sides have length 45 centimeter and 60 centimeter, and its perpendicular height is 20 centimeter. The length of the prism is 80 centimeter. Work out the volume of the prism. Now, for a prism, the volume is equals to area of cross section multiplied by area of cross section multiplied by height of prism. Actually, a prism is a solid or a 3D shape with two identical flat ends and parallelogram sides. We can see the flat ends of this prism is the shape of a trapezium. So we look for the area of this trapezium of one of the faces, these flat faces, multiplied by this height. So first of all, let's calculate the area of this trapezium. And area of a trapezium is half into bracket a plus b multiplied by height. This a and b are the parallel sides, so you add them. This 45, the parallel side, this 45 centimeter, and this 45 centimeter is the A, and this 60 centimeter is the B. So you have half multiplied by 45 plus 60 multiplied by 20. So this is the same thing as half multiplied by 45 plus 60 will give us 105. Then multiply by 20. Everything here gives us 1050 centimeter square. Remember, this is the area of the cross section. To now get the volume, we multiply this area of the cross section by the height. So by the height or the length of the prism. The length of the prism is given as 80 centimeter. So the volume of prism is 1050 centimeter square multiplied by 80 centimeter, which gives us 84,000 centimeter cube. All right, we go to something a little bit tasking here. We have a question here. Which says a cylindrical container 30 centimeter in diameter holds approximately 30 liters of oil. How far does the oil level fall after 1 liter of oil has been used? A cylindrical container 30 centimeter in diameter. So this is like a sketch of the cylinder, and it has a diameter of 30 centimeter, and then it can hold approximately 30 liters of oil. That means from top to bottom here, when it is filled up, it can hold 30 liters of oil. 30 liters of oil is the same thing as 30,000 centimeter cube of oil when it is filled up. So how far does the oil level fall after 1 liter of oil has been used? So when it is filled up, the formula for calculating the volume of a cylinder is pi r square h. Here we were given when it is filled up, we're given the volume and then the diameter. We can get the radius here, but there is no height, or the height of the oil when it is filled up is not given. So what we are expected to do here is to calculate the height of the cylinder when it is filled up and the height of the cylinder when 1 liter of oil is removed from it. All right, so let's go straight to the calculations. Here, the volume of a cylinder is equals to pi r square h. So at 30 liters when it is filled up, we have volume, which is 30,000 centimeter cube, equals to our pi is 3.14 multiplied by our radius. Remember, the diameter is 30 centimeters, so our radius is half of the diameter, which will be 15 centimeters. So we have pi 3.14 multiplied by radius, the square of the radius, 15 square, multiplied by the height. So you have 30,000 is equals to 3.14 times 225, which is 15 square, multiplied by h. 3.14 times 225 will give us 706.5, then multiply by the height. So our height, when the container or the cylindrical container is filled up, is 42.46 centimeter cube. 42.46 centimeter. Now, when 1 liter of oil is removed, remember the height of the oil in the container will reduce. Alright, now let's calculate what the height or where the oil will get to when 1 liter of oil is removed from the container. So we have 29,000. Remember, 1 liter of oil has been removed. That is 1,000 centimeter cube of oil has been removed from the 30,000 centimeter cube. So we'll be left with 29,000 centimeter cube equals 3.14 times the radius, which is 15. You square it, multiply by the height. So you have 29,000 equals to pi 3.14 times 225 times height. So this is going to give us, to get our height, we are going to have 29,000 divided by 706.5, which give us a height of 41.05 centimeter. So when the container is filled up, the height of the oil in the container is 42.46 centimeter. When 1 liter of oil has been removed from the container, the height of the oil in the container is 41.05 centimeter. Now the difference is height is how far the oil level falls. Remember, from this diagram, you have when it is filled up, the height is 42.46 centimeter, and when a liter of oil has been removed, the height is 41.05. So to know the difference in height of the oil, when 1 liter of oil has been removed, it's going to be 42.46 centimeter minus 41.05 centimeter, which is equals to 1.41 centimeter. So that is how far the oil level falls after 1 liter of oil has been used. So thank you for watching this video. In our next video, we are going to move to surface area of solid shapes. Thank you very much for watching.